Okay, number 3. Stephen is a pizza delivery driver. He earns $8 per hour. H. So H is hours. Plus an additional 75 cents for each delivery, D. Write an equation to represent what Stephen's earnings, to represent that Stephen's earnings were $286 before taxes last week. Okay, so let's highlight the vocabulary stuff again. Here's my list. Okay, I see $8 here, and I see the word per. What does per mean to do? What is it telling us to do? Multiply. So we're going to multiply the 8 times what? Times H. We don't know what H is. They're telling us to use the variable H. So there we have $8 times the number of hours. What does that mean? Plus is a vocabulary word. That just means add, right? Okay, plus an additional 75 cents. Oh, now we have the word each. The word each and the word per kind of serve the same purpose, don't they? Right here. Per and each. They both mean multiply. So here we're going to multiply the 75 cents by what? By another variable. We don't know how many deliveries he's making, but however many deliveries he makes, you multiply that by 75 cents. All right? So you have $8 times all the hours he's working. You're going to add that to 75 cents times all the deliveries he makes. Okay? And they want us specifically to write the equation to represent, and they're telling us how much money he makes. So this is going to be basically the front of our equation. Let's go down to the template and take a look at how it works out. Okay. The 286 ends up being on the answer end of our equation. The word were is very similar to the word is. It just means equals. We have our two little miniature math problems. 8 times the number of hours. Here it is. 8 times the number of hours. We have our plus sign. 75 cents times the number of deliveries. Times the number of deliveries. That's your whole equation. When we write it out, without the template, 8H plus 0.75D equals $286. Can you solve that as it is? No, you don't have enough information. But if you knew one of the missing things, if you knew the number of hours he was working, you could solve it and figure out how many deliveries he would have to make that money. Or if you knew how many deliveries he made, you could plug that in and you could figure out how many hours he'd have to work to make that money. Okay, those are the same types of literal equations we did on our last test. We okay so far? This is a lot, and really you're going to see how well you're doing when you start on the homework. And we're going to give you a lot of time in class to do the homework. All right, let's go down to number 4. A rectangle has an area of 105 square units. I would even underline rectangle because that's important. It's telling us what the shape is. Okay, area is important. Okay, notice this stuff's important, but it's nothing on our vocabulary list. It's stuff that you've learned in previous years, and all that stuff applies. The length L of the rectangle, L, is, what does is mean? The word is. Equals, the length equals 1 more than. What does 1 more than mean? Here's more than. 1 more than means what mathematically? 1 plus. What does twice mean? Twice is down here in our vocabulary. What kind of math is this? Yeah, it's just 2 times. 1 more than twice the width, or 2 times the width. So the length equals 1 more than 2 times the width, or 1 plus 2 times the width. Write an equation to represent the area of the rectangle in terms of the width. Okay, so again, we have 2 things we're going to do. First, we have length, L, is equals 1 more than 2 times the width. That's basically what we had already come up with right here. Length equals 1 more than 2 times the width. Okay, but now there's no information in the problem about what we're plugging in here. So how do we get it? You guys have been learning area of rectangles for like, I don't know, a million years now, right? You already know that area of a rectangle is equal to the length times the width, right? So what they want us to do, and this is a little challenging here, they want us to write one equation, and they don't even want length in the equation at all. They want just width. So how could you do that? How could you write one equation that represents this, but we're not even going to have the length in there at all? It's just going to be all W. Any ideas? Remember literal equations? You can solve for any of the variables. Can we solve? You have an idea? Go ahead. Divide the L. So if we got the W by itself, we would have on this bottom one W equals something, right? And then what we could do, actually we don't want to do that. Here, you said divide the L, right? We actually want to, you did the same thing that I did on a previous period. You actually want to get the W by, the L by itself. Because if we isolate the L and we know what the L is equal to, then we can just take that whole equation and plug it in the place of L on the top equation. Okay, I'll go ahead and, but you have the right idea. Good job. What I'm going to do, we're going to actually get L by itself on this bottom equation. A equals L times W. Okay? I want to get the length by itself. So I'm going to divide both sides by W. So what is L equal to? L is equal to the area divided by the width. Now that I know what L is actually the same as, it's this, I could put this over here. I could. That's one way I could do it. There's another way I could do it, but that's one way. As long as you write the whole equation in terms of W and you don't have any length in the equation, it's fair game. So where I see L over here on the left-hand side, I can put A over W instead equals 1 plus 2 over W. We wrote the whole equation and there's no L inside the equation at all. Is there other ways you can set it up? Sure, there's other ways. But that's one way. And that way is plenty good. Okay, notice, once we get the equation, we're not doing any math. We're not solving, we're just getting the equation in the form they want and we're moving on. That's all we're practicing today. Okay, we have a little time. We'll do this one real quick. This one has no template, but this one's actually pretty straightforward. Okay, digital songs are $1.50 each. Digital videos are $2.50 each. Okay, they want us to use S for songs. They say right here. They want us to use V for videos. And they want to write an equation to represent how much Marcella could purchase with $20. Okay, what does the word each mean on our list? It means multiply. So what we're doing, we're multiplying $1.50 times the number of songs. $1.50 S. $1.50 times the number of songs. The word and means add. And then we have $2.50 times the number of videos. Okay? And that's all going to equal up to $20, right? That's it. You set it up. $1.50 times all the songs you buy plus $2.50 times all the videos you buy equals the amount of money they could spend. And that's it. Okay, we're going to pass out the homework.